Welcome my dear students to my channel Mathematics Made Easy. In today's session we will be working on the lesson linear optimization. Our learning goals would be to use linear programming problem to solve questions and to also solve some important word problems from this lesson. Make sure you watch the video till the end so that you can take maximum benefit. Also, you will understand both kinds of method, the long method where you do the graphs of the linear inequality and constraints in the long way, and also check your answer from the shortcut on Desmos graphing calculator. So let's get started and watch this important video on the lesson 5.5 linear optimization, made especially on the request of my grade 11 advanced girls. So in this lesson, we will be using the key concept of vertex theorem for optimization, very important. So I will read it for you and then I'll explain. If a linear programming problem can be optimized means we have to find maximum or minimum. Then the optimal value will always occur at one of the vertices. Can I say vertices are the corner points? Look at this polygon graph. This x-axis, y-axis. In between the shaded region is your feasible region, and you have some sort of feasible solutions at the corner points, at the vertices A, B, C, D, E, F. 6 points are given. So at each of the vertices, you will have set of feasible solutions. So what we are going to be doing in these problems, we will have an objective function, which will be generally a function of x and y. So in this objective function, if we want to find the maximum or minimum value, we will be calculating the value of this objective function at each of these corner points or each of these vertices. So if there are 6 points, we calculate 6 values and then we compare which one is more, which one is less. Maximum would be at one of the points, and then minimum would be at one of the points. Those values of x and y would be your answer. So now that we know the theorem, we will now solve questions. For that, we will be doing 3 steps. I want you to remember these 3 steps, very important, and then I will show you in the next slide example 1 where we will apply these steps to get our answer. So in step 1, you do the graph of each of the region corresponding to the solution of the system of constraints. In a proper linear programming problem, you generally write it as LPP. The full form is linear programming problem. So in a linear programming problem, you will be given an objective function, which will be a function of fx, y, two variables. We have to maximize this or minimize this. That is, we have to optimize this. And there will be some set of conditions or constraints. So generally, these will be linear inequalities. You already know how to graph it, and each of them will give you a shaded region. We will take the common shaded region, the feasible region, and the corner points or the corners of the vertices of this region to be the coordinates. We will find those coordinates, means those values of x and y, and then at each point, each vertex, we will find for the objective function using substitution, we'll evaluate, we'll find the value of that function. Then we compare. If the question is asking for maximum, we give the maximum value. If it is asking for minimum, we give the minimum value. If it is asking for both, we give both the values. Okay, so these are the 3 steps. Let's apply these 3 steps now to solve question. We'll begin with example 1 now in the next slide. Okay, so let's do the first example together. So in first example, definitely you are given an objective function, which is a function of x and y, x plus 3y, and you need to find the maximum and minimum, both the values of x and y subject to the following constraints. So 1, 2, 3, 4. 4 conditions or 4 constraints are given. So step 1, we do the graph of these 4 inequalities. The graph will look like this. All are linear graphs. Then we take a test point 0, 0, graph them. So the shaded region you will get. This is the shaded region. Let me just highlight. So the blue part, this blue shaded region inside is your feasible region. Now, as you know from the theorem that the solution will have the set of feasible solutions coming from the corner points. So 1, 2, 3, 4. These are the 4 vertices. At each of these 4 vertices, in the next slide, we will calculate the value of the objective function and then select maximum and minimum. So for example, this is 0, 0, similarly this point, this point, this point, and now let's find the value of objective function. So now we'll find the intersection point or the solution of the inequalities. So the intersection point for x plus y equal to 8 and 2x minus y equal to 5 comes out to be this point. For 2x minus y equal to 5 and y equal to 0 is this point, and for x plus y equal to 0 and x equal to 0 it's this point. So at each of these points for the objective function we will find the value. So this is the value at 0 comma 0, which is 0. At 5 comma 0 the value is 2 point something. At point 13 by 3 and 11 by 3 it is this value, and at 0.8 it is this value. So we need to select maximum and minimum. Obviously minimum is 0, which occurs at the point 0 comma 0, and maximum is 24, which occurs at the point x equal to 0, y equal to 8. So this is going to be a final answer where you mention the maximum value and the point, minimum value and the point. That completes your linear programming problem. So in a similar way, I would urge you to try these questions. Here I have provided you the answer key with a graph from Desmos graphing calculator, the corner vertex points, and the final answer for maximum and minimum values of objective function. Check your answer for the guided practice 1A and 1B. Now let's solve a word problem on maximizing profit. In this one, you are given two varieties of shrubs. One is junipers, one is azaleas. So a garden center grows only junipers and azaleas in a greenhouse that holds up to 3,000 shrubs. So the total number is 3,000 due to labor cost. The number of azaleas grown must be less than or equal to. So this inequality 1200 plus 3 times the number of junipers. The market demand for azaleas is at least means minimum, twice that of junipers, so 2 times. The center makes a profit of 2 dirhams per juniper and 1.5 dirhams per azalea. So first thing you need to do is to write the objective function, and definitely it will come from the profit because that is what you have to maximize. So let x be the number of junipers and y be the number of azaleas. Then the objective function, which is a function of f of x of y, will come from the profit function. So for 1 juniper, the profit is 2 dirham. So for x junipers, the profit will be 2x. And to that profit, you add the profit of the azalea. So for 1 azalea, profit is 1.5. For y azalea, the profit is 1.5. So total is f of xy equal to 2x plus 1.5y. That's your objective function. Now the conditions, the constraint. Definitely x should be positive, y should be positive, because the number of junipers and the number of azaleas, there are some quantities which cannot be negative. Also, you are given some conditions from the word problem, so we will take that into factor. We know the number of junipers and azaleas is maximum up to 3,000, so x plus y should be less than equal to 3,000. It can't be more than this. That's the maximum capacity. Then you also know that the number of azaleas grown must be less than or equal to 1200 plus 3 times the juniper. So it's this condition because azaleas is y, so y less than equal to 3x plus 1200. Lastly, you know the market demand for azaleas is at least twice that of junipers. So y will be greater than equal to 2x. So 1, 2, 3, 4 and 5. There are 5 conditions, 5 constraints. So in part 2, we will do the graph. So now we do the graph where on the x-axis we put the number of junipers. On the y-axis we put the number of azaleas. So we take the scale and plot the points accordingly. When you sketch the graph, the shaded polygonal region will have 4 vertex points, as you see 1, 2, 3, 4. At each of these points, you calculate your objective function. Put 0, 0, 0, 1200, 450, 22, 2550 and this point, and when you substitute, the following 4 values will come. We want the profit to be maximum, so it is greatest at this point. So the maximum profit is 5000 AD, and this occurs when x is 1000, y is 2000. That means the garden should go 1000 junipers and 2000 azaleas. This is how you solve the word problem. Now try one unsolved guided practice question yourself. Okay, so let me give you some hints. We'll do it together and then I'll show you the correct answer. A lumber mill can produce 6,000 units of product each week. To meet the need of its regular customer, the mill must produce at least 150 units of lumber and at least 225 units of plywood. So what are the two categories? One is lumber, one is plywood. Okay, and at least means minimum. So we will get one condition for lumber, we'll get one condition for plywood from here. Then we want to make the objective function, which is definitely the profit function. So f of xy, which will be a function of both xy. If I take lumber to be x, plywood to be y, then the profit is 30 dirham for each lumber, so 30x, plus 45 dirhams for plywood. So this is my objective function. Now what are the conditions? The condition is that the lumber mill can produce 600 units of product each week. Okay, so this is going to be the maximum. Also, you have at least 150 units of lumber. So x has to be more than equal to 150. Similarly, y has to be more than equal to 225. Again, the combined condition, which we did not write till now, is that the sum total, it can produce 6,000. So this has to be less than equal to 6,000. 6,000 is maximum value. Okay, so we have got three conditions. Also, x will be positive, y will be positive. We are dealing everything in first quadrant. So 1, 2, 3, 4, 5. 5 conditions, one objective function, and you draw the graph. Here I've shown you the answer of Desmos, so you get the triangular shaded region, this one. And for this, the 3 points, 1, 2, 3 are the vertex points. Now we'll calculate our objective function, which is actually our profit. So we really want to maximize it at each of these points. The point where it is maximum would be your answer. So you can make a table and plug in all the values. You may take your calculator for this purpose so that you don't do any calculation mistake. This is the first point, the second point, and the third point. Okay, so just plug it in here. So this will give you 30 times 150 plus 45 times 450. This will give 30 times 150 plus 45 times 225. So out of both of this, definitely this is maximum. Let's compare the last one also. So 30 times 375 plus 45 times 225. So calculate all of these numbers to get the maximum. Also, we can do the graph, and from the graph, you will get the maximum profit as 24750 if you use your calculator, and it occurs when x is 150, y is 450. So this is your final answer for this word problem. Okay, so let's solve this question now. In this question, we have to find the maximum and minimum values of the objective function. So let's highlight important information, and we also need to find for what values of x and y it occurs subject to the given constraint. So this one is the objective function, fx given to you as a function of two variables x and y. As you can see, we have to find maximum and minimum, both values. There are some condition or some constraints given. Let's mark them 1, 2, 3, 4, 5. So first we need to graph these 5 inequalities, these 5 constraints which are given to you, or the conditions, and then we will calculate for each of the vertex corner points using optimization theorem the value of maximum and minimum, and then what points exactly. So this is my x-axis, this is my y-axis. First I will tell you how to draw it from the graph, and then we will also check our answer from Desmos graphing calculator. So this is the first equation. Let me write it in equation form. 3x plus 4y equal to 12. So if I want to graph this, I need some points over it. So what I can do is I can take different values of x and y and then take the table of values and plot it. So let me take x as 0. When I take x 0, 4x is 0. So 3y equal to 12 or y equal to 4, that's 1 point. If I take y as 0, this is 0. So x is 3. So 2 points I have got, the x and the y intercept basically. So when x is 0, y is 4. So 1, 2, 3, 4, this is the point. And then this point I can mark also 0, 4, first point, and then 3, 0 on the x-axis, 1, 2, 3. So this is point 3. Now I join these 2 points with a straight line, and then extend it in both directions. So this is my straight line. But in this question, you see there is an inequality greater than equal to. So two options, either I can go left or I can go right. Now I need to see which one is true. So I take a test point. For example, I take 0, 0. I put x as 0, y as 0 in this inequality. So 4 times 0 plus 3 times 0 is greater than equal to 12, or 0 is greater than equal to 12. Is it possible? No, it's not possible. It's false. So that means 0, 0 test point does not lie. So I will take the right part of the graph, this part, not the left part, because left has 0, 0. So this is the graph of the first inequality. Now y equal to 3. If I convert it in equation, then 1, 2, 3, this is the line. So y equal to 3 means the horizontal line. So this line is y equal to 3, and definitely it is parallel to the x-axis, because x-axis is y equal to 0 and it passes through this point on the y-axis. Now I want y to be less than equal to 3. So again, can I take test point 0, 0, and is 0 less than equal to 3? Is it true? Yes, it is true. So I will take the bottom part. So this is the shaded region of second inequality. Now y greater than equal to 0 means x-axis. So I will take this part on the positive direction going up. That's for the third inequality. Then x equal to 4, that means 1, 2, 3, already I did, this is 0.4. So the equation, I will just change color, would be a vertical line, x equal to 4, I will pass it on. So this is the graph of x equal to. Now I want my x to be less than equal to 0, sorry, less than equal to 4. So I put test point 0. Is 0 less than equal to 4? Yes. So it is going to lie. That means I will take the left side. So till now, the common shaded region for all of these lines has come out to be this. So I will just highlight this point. So this is my shaded region. Okay, and I can check it also from the graph. Okay, so this is the shaded region. Now I need the corner point, so maybe I just change the color. So this is one corner point, second corner point, third corner point, fourth. Now this we already know, this is 3 comma 0, this one is 4 comma 0. What about this point? Let's see. So x equal to 4, y equal to 3. So 4 comma 3, this point. So the only point we need is this point. So let's calculate this point also. So now we write the vertex point or the corner points. Now in the next slide we'll be using the optimization theorem for this objective function, and we will try to find maximum and minimum by taking these corner points. So what are the 4 corner points? Let's write. So 4 comma 3, 4 comma 0, 3 comma 0, and one more point is this one, which we still need to find. Now I know this point is lying through this line, so it will have the y coordinate is 3. Now I just need the x coordinate. X coordinate will be little less than 1. So this is the meeting point of y equal to 3 and this line. So in the first line I put y as 3 and I will get the x value. So let's get it. So 4x is 12 minus 3 times 3, 12 minus 9, which is 3. So your x is 3 divided by 4, or 0.7. So we've got the fourth point also. So this 4 point has x coordinate 0.75 and y coordinate 3. So now at these 4 points, we will try to find the maximum and minimum value. We will be using the method of substitution. In place of 3x plus 3y, we will be putting these values. These are all points x comma y. By substitution, we will see which point is giving me the maximum and minimum values. Let's do it in the next slide. Okay, so now I make the table of values. I write all the points. So the vertex points, and here we write f of xy, the objective function. So 3x plus 3y, we will calculate the value at each of the 4 points. 1, 2, 3. Let me just make some rough table. You can use ruler. I'm doing it without it. So one point was 3 comma 0, then 4,0, then you had 4,3, and then 0.75, 3. Okay, so let's put in. So when I put 3 times 3 plus 3 times 0, I get 9. 3 times 4 plus 3 times 0, I get 12. 3 times 4 plus 3 times 3, I get the maximum value here, you can see. So this is 12 plus 9. So this is 21. Definitely this is the maximum value. Let's do the last one also. So 3 times 0.75 plus 3 times 3. So this is going to be, let's do the calculation, and I hope you know that I'm using substitution while I do this calculation. So you can do it on your calculator just to save time. That will be 11.25. Now let's calculate maximum minimum. For maximum, there is only one option, which is this one. So the maximum occurs, maximum value of objective function f of xy. This function is my objective function. Occurs at the point 4, 3. That means at this point x is 4, y is 3, and what is the maximum value of the objective function? We already got it from the table. It's 21. For minimum, we need the least value, and if you compare 9, 12 and 11, then this is the minimum value, and it occurs at the point x equal to 3, y equal to 0, this point. First point, we got 9 value. So this is how you get the maximum and minimum values of the objective function subject to the given constraints. Now let's check the answer on Desmos also. I will show you the graph now. Okay, so let's now graph on Desmos graphing calculator the inequalities. So the first inequality was 4x. I used this Desmos kit to graph it, and then I type the inequality plus 3y, and it was given to be greater than equal to 12. So this is how the first inequality looks. You can look at the shaded region. It is same as what we got. Second is y less than equal to 3. That's the second one. Next is y greater than equal to 0, which is your positive x-axis. Next is x less than equal to 4, which is your vertical line on the left side, including 0, 0. And then last one, x greater than equal to 0, which is your positive y-axis, first quadrant. So now I will close this toolbox, hide it, and zoom out and show you the common points. So we got the same answer, 0, 0. Sorry, 0, 3, and then the next point we got 0, 75, 3. After that, the next point is 3, 0, and finally we can get the last point 4, 3, which I will show you here. Maybe I have to zoom in a little bit more to show you the points nicely. Yes, now it's better. This is one point, this is another point, this is another point, and this is. So now you can see 1, 2, 3, 4. These are the corner points that we got when we take the common shaded region. So this part is the common shaded region, and this is how you can use Desmos for checking your answer, for graphing, and this is just a shortcut. But ideally in your exam, since graphing calculator is and Desmos graphing calculator is not used, you should do the method like I showed you in the video before. In a similar way as your homework, I would want you to try this question yourself, solving the same steps using the same method, and then your correct answer for the maximum and the minimum values for the objective function after drawing the graph of the inequalities and constraints will be this. Let's now solve a real world problem. This is a word problem, so we will highlight important information, read at least twice. A vegetarian recommends that a new kitten eat a diet that includes at least means minimum. So that means it has to be more than this, minimum it has to be. So greater than equal to inequality will be used. So this much value of protein and this much value of fat she should eat each day. Now you are given, instead of more sentences, a table. So we will now see how we use the table to write the constraints and to write the inequalities. So use this table to determine how much of each cat food should be used in order to satisfy the dietary requirements. Now there are two kinds. One is protein, one is fat. So let us take that she takes X number of, cat food of good start and Y number of Cyrus. Okay, so X represents the number of cups of good start eaten and Y represents the number of cups of Cyrus eaten. How do you know this? You know it from the table that there are two options. So the objective function would be defined using the table. So we take this values 0.36 and 0.22. So 0.3x of good start means we multiply and then we add it to 0.22 of Cyrus. So this is the total objective function. We need to use this objective function, and now we define condition. For condition, I will use these values. So 0.84 times good start plus 0.56 times Cyrus Y should be equal to the total protein, and total protein should be at least 1.54. So this has to be minimum. So the total protein has to be greater than equal to 1.54. This is your protein condition. Similarly, there is a condition on fat 0.56. So total fat would be 0.21 times x because x is good start, and 0.49 times y because that's Cyrus, and this has to be greater than equal to 0.56 because that's the minimum amount of fat she should be taking, the cat. So we have got two conditions, one, two. Obviously, the quantity of the cat food brand, whether it is good start or Cyrus, will be positive, it cannot be negative. So these two conditions also come up, third and fourth. So using these fourth condition, now let's use the objective function and do the graph. So in part 2 of the word problem, you have to sketch the graph, and you will use the good scales while you do that. So on the x-axis, I'm putting the good start cups. On the y-axis, I'm putting the Cyrus. So it's like your x-axis, y-axis, same thing. Now both are positive, so we are on the first quadrant, that's two condition. And when you plot the graphs of each one of these, you will see that the shaded region is this one, the one shaded with blue. So it is 1 point corner point, 2 point, 3 point, but from this side it is unbounded. There is no maximum or minimum value, as you can see from this end and this end. So here we just get 1, 2, 3, 1, 2, 3, three corner points, which are this, this, and this. So we calculate our objective function at these 3 points. Objective function comes from the previous slide where we take this equation. So plug in place of x0, y 2.75, you get this value 0.605, and then similarly put in the values for the other 2 points. And if you compare all of these three, then the minimum value of the objective function is coming at 0.605. However, we cannot say anything about the maximum value because it's an unbounded graph. Therefore, what we can conclude, to meet the vegetarian requirements, the minimum cost should be 0.61 per cup. So we've just rounded off. That is how much the kitten should eat to get 2.75 cups of only Cyrus plants. Why? Because X is 0. So she does not need to eat the first variety. Only the second variety, 2.75 of the Cyrus brand is enough, and the cost that would be spent would be 0.61 dirhams for each cup of the kitten food. So that brings us to the end of today's long video. I hope it helped you to understand linear optimization and linear programming problems along with word problems and graph questions perfectly well. And if this video helped you, do share it with all your friends from grade 11 advanced who will benefit for lesson 5.5 linear optimization. Until then, this is Mr. Chika signing off from today's session. Let me know in the comment section which topic you want me to cover next for grade 11 advanced term 2. Until then, see you in my next video. Bye students.